Welcome, everybody. Thanks for coming. Thanks for being here. I know some other folks might trickle in as we go, but we're going to get started. And we are still in our first week, but we are back for Coding Bootcamp. This is day 2. So we're going to talk about algorithms, applications in general, and we're going to dive into Python today. So I know it's kind of billed as Python is the thing we're using. I will reiterate a few times, it's not a Python course, but we will be using it a lot, and we're going to start today. And we're going to get hands-on with it and start writing some stuff. The end of today, our goal is to have a basic program written that we can run out of our command line that's written in Python and give you all a framework to go and then write some things and play around with it and have something to actually start running some stuff on your own from there between now and our next class. So before we dive into today's stuff, let's go over a quick review. We only had 1 day's worth of things. We did cover a lot last time. One of the big things that we covered is how computers intake information, how they process it, and what they do with it. And who remembers the way that we talked about data last time and in what context we talked about it and what we defined it as?
Well, bits and bytes.
Yes, bits and bytes.
Yeah.
Exactly.
I said that too. I was just muted.
Excellent. Excellent. All right, cool. Bits and bytes. And what are bits and bytes?
Probably faster than me.
Yeah. And so what are bits and bytes?
Numbers, one
it
or
is-
zero.
It's 1 or 0. Absolutely. Absolutely. And it's the way that computers understand what we give it, right? So the way that they process information, the way they store information, it's in ones and zeros. So that's the main concept. We're going to talk about
code.
Yep, binary code. We're going to talk about data throughout this course in a number of places. Today is another time we're going to talk about it, and it's going to be a slightly different meaning. It does always relate down to that ones and zeros, bits and bytes. But I want to call out the fact that when we talk about data today, we're going to be talking about Python and data types. And that's really what you could think of as arrangements of those bits and bytes that Python lets us use. So things like numbers and words and stuff like that. And we'll show you specifically what those are. But when we talk about data today, that's what we mean. And we're going to talk about it a couple more times as the course goes on. But that's the main part for review. Are there any questions about anything that we've done up to now? Anybody stuck somewhere that had a quick question about it?
I had a real quick question.
Sure.
Is it just Tuesdays and Thursdays that we're meeting? Just to be clear.
Yes, Tuesdays and Thursdays. And then I did want to call out, thank you actually for asking that. I didn't put in my notes. Since Thanksgiving is a Thursday, like it always is, that week's class will be moved up to Monday. So we'll have class Monday and Tuesday that week. So we'll have 2 classes that week, but it'll be Monday.
So I got another invitation for them like Monday the 23rd or something.
Yes, it's whatever. Yeah, I forget the date of that Monday, but yeah, it's that one because the Thanksgiving is the 28th. So
Okay.
cool. Any other questions? Thank you for that one, Nathan. I appreciate it. No? All right. Cool. So, quick bit of theory. We're going to talk about algorithms and understand what they are generally for our purposes and how we're going to be interacting with them. So, start, what is an algorithm? Let's just define it. So, it's a set of instructions on how to complete a task, right? So, the analogy that's often used is giving directions to somebody to make a jelly sandwich. Who's seen that example before on someone giving someone else directions on making a jelly sandwich? Is that something you're familiar with?
Yeah.
Yeah.
Hardly
So
ever goes well.
Yeah, it never goes well, right? And that's the idea, is that it's used in several contexts on how to communicate ideas. And when you try to give someone directions on, take out a piece of bread and put jelly on it and do these things, the way people understand what seems to be simple directions can go off the rails. And computers are even worse because they have no context. You have to give them literally every bit of what you need them to understand. So think about breaking down, telling someone else to make a jelly sandwich as sort of the analogy for what we're doing. I've done this in past classes where we actually walk through it, but it takes a lot of time, and I want to get more hands-on with Python today. So we're just going to keep that analogy in mind. And then talk about the key characteristics of what an algorithm is in the sense that we're going to be using it. So they're finite. It's got finiteness, meaning it's got to terminate at some point. It can't just be an infinite number of things that goes on forever. Each of those steps has to be a clearly defined thing that does something specific. Each step is a clearly defined process. There has to be some sort of input that's accounted for. 0 is a concept that we keep in mind. So 0 inputs, like the function that we wrote last time, the or I'm sorry, we haven't written a function yet, but the no inputs that we're going to use today count as inputs. And then outputs are all the things that come out of it, right? So algorithms have inputs and outputs, have to be kept in track of and accounted for. And it has to be for a purpose. It's got to be effective, overall effectiveness. So it's got to be solving some kind of problem, designed to solve a problem, designed to do a specific thing. So these are the broad characteristics of any algorithm. So we talk about applications, and we're going to just quickly skim over the ideas of testing and debugging. But when we talk about applications and we define what that is, it's a program or any piece of software that's designed to solve a user's problem, right? So it's generally speaking a collection of algorithms that's just solving a whole bunch of little problems for some larger problem. So any application could be Zoom, like we're using right now, or slides that I'm using right now to do this presentation, or Python Anywhere. Those are all applications. Very common usage. We all know that. If you've done any sort of coding before at the basic levels, they usually have an introductory thing called Hello World that you write that just prints out Hello World somewhere. We're going to do that today. If you haven't, you will have written a Hello World application. So you will be able to say that you've done that. But it is a very good example of a fully formed application. It serves a specific purpose, albeit a pretty benign one of just printing out Hello World. But the mechanics are the same, whether it's ChatGPT or this Hello World application. The principle of it follows a specific set of steps and gives you a result that you wanted to, or that you expect, is what the application is doing. So again, it could be very simple, it could be complex, and they can run on any number of platforms. We're going to run ours straight out of the command line. We're going to be building towards a web browser. But again, these concepts can be applied to mobile applications, desktop applications, any number of places that an application can run on any platform. The same principles apply. So debugging, we're going to get a lot of practice on this, but it's generally speaking a systematic process to find these errors in a computer system. And there are a couple of, there's all kinds of different bugs that exist, but I want to talk about a few specific ones that we're certainly going to run into. We probably already have a few places, but we will from here on out. Things like syntax or type errors. So syntax errors are when you write something incorrectly in the language that you're writing it. So if you were doing things in the bash console and you capitalized one of the commands, or you put a space and you actually wrote the word print working directory instead of PWD, those would be syntax errors. And it's something written incorrectly. Another type of error is called a type error. And when we get into data types today, I'll show an example of this. It's when you try to do something with a particular kind of data that you can't do with that data. So think about doing something to a number that you can't do to numbers. These kind of things are really common, but they're found in the compilers and the interpreters. Another kind of error, logical errors, are the kinds of things where you make a mistake in the logic that you used to make your program. And those will not be caught by a compiler or an interpreter or any program. You have to make some sort of thing or find a way to find those logical errors. So generally do that with testing. But another one that I want to call out as we get going on this is a very, very common one, especially when you get started. It's called an off by one error. So when we talk about data types today, we're going to talk about some sequential things, and they have an index or a place in the list that they're in. The first place in most lists is going to be 0, not 1. And so a lot of times if you're counting things and you're expecting things to be a certain number of things, like you have 5 things in your list, the position of that last spot is going to be 4, not 5. All kinds of problems happen with that, right? So these 3 things are types of bugs that I wanted to call out, kind of keep in our minds as we go forward with what we're doing. So again, debugging is a systematic process of finding this. This is a whole job. If you're quality assurance, that's what this is finding bugs, fixing them, possibly, definitely finding them. Anybody that's interested, I know we had a couple of folks mention things like cybersecurity. The things that you do in debugging and testing are real similar to the kinds of stuff that are valuable for people that are in cybersecurity, even though there are very different disciplines. Doing testing, QA, and things like that is one set of things. But the looking through logs is a place where you can find weaknesses. So for cybersecurity, it's very relevant. But testing is a way to test things like testing your logic. You could put expected inputs or like known inputs and expected outputs. We're not going to spend a ton of time on building our own tests or writing our own tests for applications, even though it is something that should be done continuously through development. We're going to kind of gloss over that in this course because it's a little too much to take on. Next week, when we do our algorithm practice things, there are some tests built in, and we'll talk a little bit more about how those are structured and how you might want to use them yourself for things moving forward. And that should be just about all the slides that we needed for today. We're going to go over to Python Anywhere. Does anybody have any questions about any of those things that we quickly went through today conceptually?
It might be more of an etymological question, but why do we use the word application instead of just program?
That is a good question. I actually don't have a good answer for that.
Like,
Man.
I remember growing
I'll
up,
go
I
look that
never
up.
heard the
Yeah.
word application. I
Yeah.
heard program, and
I
now
think
all of a
it's-
sudden everybody says apps.
It's interchangeable for sure. I'm not sure now you're going to get me down a rabbit hole figuring out when that changed, but I don't know a good reason to tell you why that is. That's an interesting question. Anything else? But I mean, as far as I know, to answer your question, it's interchangeable. They mean the same. So program application is one more popular now. Maybe.
Yeah.
No. All right. That's it. Last chance for questions. I'm joking. Shout them out as they come up. We're going to jump over from this into our Python Anywhere dashboard, and we're going to go back to, actually, I'll just go straight to consoles because it'll be easier. So let me get this Zoom stuff out of my way here. Consoles. And so we should have maximum of one console today because we're probably, if we get to the endpoint that I want to get to today, we're going to need two. So if you've got more than one console listed here where it says your consoles underneath the consoles tab, close one of them out and make sure that you have a bash console that you can get into. If you need to start a new one, you don't have any, you want to, under this start new console, and just click under the bash where it says other. We're doing a bash console. So you can follow along, and let's hop in. Right. Cool. So quick refresher. Who remembers? Let me zoom in so it's a little more visible on the screen. Who remembers what this little tilde symbol is shorthand for?
Kind of
directory.
showing where we are, home user.
Very good. Okay, cool. And who remembers the command to check where we are if we wanted to verify that?
PWD.
Very nice. All right, cool. So there's the whole thing. All right. So today, what we're going to do is we're going to start playing around with Python. We're in our home directory. And we remember the bash commands that we did last time. That's great. What we're going to need to make sure that we have first is that we have Python. Now, we got on Python Anywhere, we know that we have it, but this is a good rule to make sure that your system has whatever it is you think it has. And if it doesn't, this is a good way to check without breaking anything. So use the version flag. Sometimes, again, it could be a single dash and a V, but this tends to be more reliable. So I tend to do 2 dashes in the full word version. And this should tell us what version we have, right? So if you're doing this outside of Python Anywhere, if you're doing this on your own system someplace, and before you start, you want to make sure you have it. And I also want to call out, if you're going to be working with Python, the version is very, 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 very relevant. So most things at this point are going to be in some kind of version 3. We'll go into version later in the course on specifically what this is saying. But for the first time, we'll go back over it. These 3 numbers mean something. And the first number is a major version. And so it's not going to work with older ones. The middle one is a minor version. It'll typically work with older versions. This is not the latest. There's a 3.12, I think, that's out there. And then this is going to be like patch versions. So those are always going to be backwards compatible is the assumption. But you could change those and mess with it. This is fine. The standard one we have here, we don't have to download anything or do anything with it. We'll just, for our purposes, we don't need the latest and greatest, which again, I think there is a 3.12 that's out there now. But this is a way to check that you have Python installed. If you don't have whatever it is that you called this version thing on, it'll just say that you don't have it installed, but you can install it with whatever you need to install it. And we'll do some installation of things down the line. But this is a good handy way to check first thing. All right. So now we're going to shift from, so far we've been like all those print working directory. And if you remember LS, the list that shows us where, what's in the directory we're in, those things have been bash commands, right? And that stands for born again shell. This whole thing could be called a shell, and born again is like another version of it. So it's called bash. What we're going to do now is go from here into a Python interactive shell. And so what we're going to do is we're going to move into Python. It's going to look similar, but it's going to change into something else. And those bash commands aren't going to work anymore. So I'm going to show you how to get in and out of that so we don't get too stuck. But the first thing we do is going to write Python, and then we put the number 3 at the end. Not required, but this is to make sure that we are using a 3. There could be 2s out there someplace, so I do this just to make sure. It's just force of habit. So when I do that, it's going to give us, once again, the version information of what's installed. It's going to say some other things. And you'll notice that the $ and the tilde and the UTC time changed to these 3 greater than symbols. That's how we know that we got into our Python interactive shell. So right now, if I type in, say, ls, it's going to give me this error. It's going to say name error. We don't know what this is, because that doesn't exist in Python. There is no ls command like this, and that's not how you do commands in Python. So this doesn't work. Another thing is not as easy for me to clear the screen, so it's going to be a little jammed down at the bottom. That's just kind of unfortunate as well. I can hit enter a bunch of times, but it'll still be writing at the bottom. All right, so now that we're writing in Python, what I want to do is demonstrate a few of the ways that you can interact with this and talk about the building blocks, the data types, as they're called, or how Python groups data, right? I'll send out a list of the things that we go over to make sure that you got the definitions clear afterwards, but I definitely encourage you all to write along with me so you have these saved in the history like you would before. Before we dive into that, though, I'm going to show how to get out of this and get back into your Bash terminal, because we are inside of that. So the way to get out of here, you just write the word quit, all lowercase, and then open quotation marks and close quotation marks. I'm sorry, quotation marks, parentheses, open and close parentheses. And this is a Python function. This will become very, very familiar with these as we go, but this will take us right back out, and you see that those 3 greater than symbols turn into our UTC tilde and $. So once again, to enter the interactive shell, actually, hold on, I'm gonna clear my screen real quick now that we're back in Bash. So to enter the interactive shell, I'm gonna do Python 3. I know I'm in Python because I got the 3 greater than signs, and if I want to leave, I type quit with the parentheses. Parentheses. Yeah, parentheses. Open and close parentheses. All right, cool. So there we go. Basic mechanics of getting in and out of the shell. So now we're going to talk about data types. The first basic data types that we're going to go over are types of numbers and the way Python deals with numbers. So it could take straight integers. You could just put in, like, write in integers, and it understands that. So if you type in the number 9 and hit enter, it'll just spit back 9 at you. It recognizes that as a thing. You can do basic math with these things, and it'll do math for you. So you can do this directly, right? Which is all fine and great. The other way that they treat with numbers are with decimals in them. So a floating point number can recognize those as well. And you can do basic math with these sorts of things, and be aware that these are 2 different types of data. A floating point number and an integer are 2 different ways of interpreting the data and ways of using the data. But if you see that you use things that are 2 integers and just divide them, it'll return a float. So a way to get around this is to do floor division, and that'll give us an integer for sure. So you do 2 division signs and do that. So basic arithmetic can be done directly in Python. And we'll be able to take these building blocks and build them into more complex things. So we can add them, we can subtract them, we can do exponents, we do things with power, the base number, 2 asterisks, the power, multiplication is also with an asterisk, 2 times, let's say 9. All right, so these are integers, these are numbers, and floating points, or numbers with decimals, right? So that's one way that you can interact with Python. You can give it numbers and math, arithmetic things. It understands that directly. Very simple. The next very, very basic data type is called a string. And this is anything that is contained in quotation marks. So you put it inside of quotation marks, and then inside of either double or single quotation marks. So put it in doubles and return it in singles, but you can't mix these. So if you start with singles, it's got to be singles everywhere. Start with doubles, got to be doubles. We'll play with these a little bit. But strings can be anything. This can be symbols. This can be numbers. This can be words. Think of this kind of like text almost. This is sort of what we would think of as text. So everything that's considered a string in Python is text for it. So this is not the same as that. the two different data types, even though for us, we're looking at 9 in both situations, right? And I could prove that because, like I said, we could do mathematical operations, arithmetic operations with an integer 9. Let's say you multiply it by 3, and it'll do that math for us. It gives us 27. Great. Now, if we write 9 as a string and we do times 3, it'll just write that string 3 times. And it'll do that with any string that you put in there. So you could put string space is included as part of that string. So white space is one of those things. And it'll just write that string 3 times. It'll repeat the string. Right. So these are, that making sense to everybody? Understand how this data type being surrounded by quotation marks is not the same as this data type? Without diving into the computer science of why.
Yeah, so it's basically, if it's in quotation marks, it's basically like a quote. It treats it as like one unit, unchanging unit.
Yes, and that's actually, yeah, that's a really good way to think about it because they do change. There are ways to pull parts of it out and we can do some manipulation with them. But yes, you can think of it as being treated as one holistic thing that does not change. Cool. So these things that have been writing so far were called literals. So we do like you might see that in documentation. You might hear people call those things as string literals or integer literals or something like that. It's when I'm actually writing a number or a string or something like that. They can also be decided or like set aside or understood by Python using built-in functions. So we already saw a function of quit. This was a function to get us out of here. I'm not going to quit to get out of here. But if I wanted to do like this, int is a built-in function that can change a string into an integer, or it can force a float to be an integer. It can change the type of data that you give it and make it something else. And other way around, you can do string, give it an integer, and it should give you a string version of that thing, right? So there's ways to change the type of data that you're using these functions of similar names. And you can also use them as placeholders when we start getting into variables. I'll show you how to use those as well. But the last thing I wanted to talk about before moving on to those is Boolean values. So that's very simply just the true and false values. But these are reserved, what's called reserved words in Python. So capital true and capital false are the words that are reserved. They actually exist in Python as those things. If you do lowercase true, it's going to say name error. I don't know what that is, just like we did when we got the bash command ls. So these words can't be used for other purposes, and Boolean values are not typically things that you're going to like use expressly, but you're going to use them in your logic when you check for conditions to see if things are equivalent. For example, it's a very common way to do it. Like we would say, is 9 the same as the string 9? And we expect it not to be. And this little piece here with these two, what we would call equal signs, you got to kind of get out of the habit of that, because when there's 2 of them, it's equivalence in Python. When it's 1 of them, it's assignment, which I'll show you shortly. But this is like, if you read this out loud, the whole phrase, I would say 9 is equal to the string 9. And it's a statement. It's a logical statement, right? So what it's going to give me back is a Boolean on whether or not that statement evaluates to how truthy, as they like to call it, that statement is. This is a false statement, right? So that's a Boolean value. That's another data type that you need to keep in mind. And it similarly has a built-in function. This, again, usually just will check the truthiness of whatever you give it inside of this function. All right. So the next, those are, I guess, kind of the most basic pieces. And from there, the next data types that we're going to talk about are in some ways collections of these. So the first one that we're going to talk about is variables and how we set them. Variable is a concept, just like high school math. It's exactly what it sounds like. It's a thing that represents something and can be changed, right? So we're going to talk about the rules of setting, creating, changing variables at a very high level in Python, how we do it. It's really simple. You just come up with basically any word you like that's not a reserved word, so none of this false. There's a handful of other ones like in and if and those sorts of things. And it can't start with a number, so you can't have like, say, 1 variable or something like that, right? It has to start with a word, but you can have a number in it. So you could have, say, my variable. If you want to have 2 words, no spaces, you can either capitalize the second word, what they call camel case, or the more commonly done in Python, underscore to separate two words. And so this is how you create a variable. You just write a name of something. So my variable, and then you set it with assignment, right? So we say my variable, this example, and we can just call it is set to 9. When you do this, you're not going to get any sort of feedback. It's not going to tell you that you did it right. It's not going to say congratulations. But what you can now do is you can call my variable. And we can use tab complete, just like we did in the bash console. You start typing M, you should be able to complete this if you're following along. And we hit enter, it's just going to give us back the value of that. And that's still there. That's great. So we can change it to something else. We can say, just by setting it like we did before, so my variable is equal to whatever, something else. And now if I call my variable, it's going to give me back what I just set it to, not what it was before. So that in a nutshell is variables. And these can be, you can do things like say comparisons like we did before, say A is this and B is that. And then say C is, I'm sorry, say the string of A. And then we can just check to see if these are the same. Say, is A equal to B? We expect it not to be. Then we ask, is A the same as C? And it'll say, no, but B should be, if I can type, should be roughly the same as C as true, right? So that's what variables can do for you. And it'll allow us to do more complex things from there when we get into the last data type where we're going to end up today when we start writing functions and things like that. But that's the first way of kind of grouping and collecting is in some sort of variable. And the other thing I really want to keep in mind in what a variable is when we define it is that it's a named space in memory. So what we do whenever we set a variable and declare that, we're setting aside some space in our memory and saying that that space is this type of data and it's labeled with this A. So now this A exists in this world. We can reference back to it. It exists in what's called our scope.
Memory or storage?
Great question. I was just going to ask that. First of all, what's the difference?
Memory is more like RAM. It's temporary, whereas storage it's set aside and you can come back to it.
Yes, very good. Memory is what you call not permanent, right? Like you said, and storage is permanent. So this is stored in memory, meaning if I exit out of here and I quit, and then I go back, I'm gonna clear my screen again because I just like doing that. And then if I go back into Python and I say A, it's going to say there is no such thing, doesn't exist because it is no longer existent in here. The memory was dropped when I quit. So it wasn't stored in any lasting way. The part that was stored in a lasting way is all the commands that I wrote. So I can just press the up arrow like I did before, and I can redefine A as something by just pressing up, and now I have it again. But it wasn't stored and kept anyway. Great question. I was just getting to that. And we're going to get to, writing this sort of thing in files and referencing those files so that you can store them in your files. And it's not exactly the same as storage when you talk about storage for your application, but it's kind of the first part of that where you can write down these instructions and make your algorithms in a file and reference that file and run your algorithms through it. And that's where we're going to get today. But so this stuff, when you do it in your interactive shell, is all in memory. Nothing here is saved. So keep that in mind as well. You don't want to go crazy writing too much, but it's a good place to play around with Python things, even as you're getting ideas and just like testing it out. It's a good place to do it. Any other questions?
So if you were to write like A equals 8 now, that would just overwrite all the previous A's.
Yeah. Now A in this context will be an 8. And again, we're glossing over how it does this under the hood and exactly where the memory is going. We'll talk a little bit more about it next week on kind of the cost of doing some of these change operations and why you'd want to use one data structure over another. But for right now, yes, just think of it as being overwritten with the new value.
Okay. What if you like make a mistake changing a variable? Is there any way to go back?
Not really. No. So the way that you're really going to do these sorts of things, the way we're going to use variables when we start writing algorithms, you got to kind of keep track of where it's changing and what it's changing to. But there are some tricks to show you at what point the variable is being used and what the value is of that variable. And we'll get into it very, very shortly at the end of the class tonight. I want to talk about one of the ways that computers do these things is called control structures. And the sequential control structure is when they read the file that we're going to write from top to bottom, left to right. So you can put in those checkpoints in those files. It's kind of part of the debugging process, is checking what your variables are and keeping track of it. But picturing that is really, like, that's kind of part of what you got to do when you're developing, is keeping track of what your variables are and what they're set to and what's changing them.
Okay.
So no, there's really no way to go back. You gotta, there is no back button. You gotta make the back button. Cool. Any other questions?
Yeah, I don't know if you went over this already, but can you define Boolean? What's a Boolean?
Yeah, Boolean is just literally the word for something that is either true or false. So it's just it's one of those. It's either a true thing or a false thing. So it's used almost exclusively when we're talking about logic, and we'll start using that soon when we do some sort of logical statement. Like we could say, are these two things the same? Is this bigger than that? And the result of those operations will be a Boolean. So the true or false is literally what that means. Nice. Any other questions? Right. Excellent. So now let's move on to some a little bit more fun, complex collections of these data that we're using. There are 4 kind of collections that are typically used in Python, but 2 of them are way more frequently used, especially as you get going. I'm gonna go over all 4 of them just to familiarize you with them, but the first 2 that I cover are way, way, way more frequently used, especially when you get started. So the first one of those is called a list. And a list is, think of it just as a list you have anywhere else. Like if you do a checklist, there are things that you write down in an order, so they are ordered, something to keep track of. The order of them does not change. So they're a thing in memory that we set aside and says, all right, great. We have this list. Everything in here has an order. They're 0 indexed, which I've mentioned before, and we'll play around with it. I'll show you what that means. And they're what's called mutable. So there's something that can change. So we can change the contents of a list. We can add things to it, take things out of it, right? So those are broadly speaking. We'll get more into those things. I want to quickly define it for you, and let's start writing them. So a list is with square brackets, open and closing. And inside of that list, we can have any of those data types we've talked about so far. So we can have just integers, and then we put a comma, and we separate our list with commas. And we could put floats in here. We could put strings alongside of there. Really doesn't matter. We could put other lists inside of this list that have other lists inside of them, and we can nest them on as many times as we like. But for right now, let's just add a couple of things so we have something in here. And I'm going to save this in some kind of variable. So let's just save this into the my list variable. And so now if I call my list, it should give me back those same things in the square brackets, just like I had them. And every single time I call my list, it's going to give me back these 3 things in this order, because this is an ordered thing, right? So it's very important to remember. Some things are not. Some things will not consistently give you this order. So if order is important, a list is something you're going to want to use. Now, the 0 indexing, what does that mean? So if I want to get something out of this list, I can reference it by its index. So I do that also with a square bracket. So I have the name of the list itself. So I have my underscore list, no space, opening a square bracket. And then I'm going to give it the integer of the index that I want. So remember, I told you this is 0 indexed, and there are 3 things here. So if I want the last thing here, what index should I put in? There's 3 things, and the first one is 0.
2.
2. Exactly. Put in 2, that should give me strings. Because if I put in 3, it's going to say womp womp, index error. The list index is out of range. You can't do that. It's too far. So 0 indexing, good to keep track of. Otherwise, you get the off by 1 error. Lots of stuff that can be done with strings. They're very, very, very useful, very versatile. We can add things to them. We can take things away. We're going to get a little more into that next week when we start talking about other data structures that are even better than lists. As you're looking through the things you're looking through, you may see the term array, which is basically the same thing. In Python, they're called lists. In general computing terms, things that are structured like this and behave this way are called arrays. They're called arrays in JavaScript. It's pretty much the same thing. This is what Python does with arrays. So that's the first data type. Any questions about that thus far? The list. Right. Cool. So the next data type that we're going to talk about, also exceptionally useful, use them all the time. It's called a dictionary. So a dictionary is not ordered. So it's not going to be zero indexed. It's not going to come up in the same order every time you do it. And the key thing to remember about that, and I say key on purpose because I really want to hammer home this point, that they come in key value pairs. So the way that you write a dictionary is in curly brackets, and then you have a key of some sort, colon, and then a value of some sort. And this pair can be separated by a comma, and you can have more key value pairs inside of your dictionary. So this is the shape of a dictionary, is what a dictionary looks like. The way that we use these sorts of things is usually set a key that you could use and reference as something. And what I like to do is maybe just an example of like my kids and their birthdays, or not their birthdays, I'm gonna write that whole thing, but let's just say their ages, right? So I got, one kid, he's that old. I got another kid who's, not quite as old. We're going to be here a while. I got a lot of kids. And then they're that old. All right, cool. So now we got all these guys in here separated by commas. And let's just say I want to just save this into my kids. So I have a dictionary that has my kids in it, right? Now, if I try to reference these things to show that it's not zero indexed, if I try to say my kids 0, if it was zero index, we'd expect it to give us just this first thing that's here, right? But it's not. Now, it doesn't say that it was out of range. The list index was out of range like we got before. We got key error 0. That means that it looked through all the keys in these key value pairs, and none of them match this. So it could have been, like we could have used 0, but we didn't. So that is how you reference a key. You use square brackets just like that, but you have to put in a key that actually exists. So I'm going to put in, let's say I forget how old one of my kids is because there's so many of them, and I just put in one of the kids' names, and it'll give me the value associated with that key. So the beauty of these things, dictionaries in Python, broadly speaking, they can be called hash maps or hash tables, is they're a lot faster at looking things up, and we'll talk about the decisions that we make on using one versus another. But that's the main one that you want to keep in mind. Sometimes it's a much faster way to do some things that you're trying to do. And it's for the specific reason, because things can be looked up by their key directly. You don't have to sort through everything or sort the list. And again, these are not ordered. So if I say, just call my kids over and over again, it might give us this same order, but if we do it enough times, it'll change, right? It's obviously not going to cooperate with me this time, but you'll see that if you do this a few times, it's not guaranteed. And if you have a larger dictionary, the order with which things are returned is not the same because it's not an ordered thing. And these, I guess the values, these can also be nested. Like we said that the lists can. The values can be dictionaries. The values could be lists. The values could be any other data type that's in there pretty much. The keys can be variables. They can be references to variables, but they're usually some kind of string or integer or something like that that you can reference and look up. Any questions about dictionaries? We're going to see these a lot when we use them a lot, for sure.
Okay, so sorry, I was playing around with it as you're saying it, and
Sure.
okay, so you called my kids Alex,
Mhm.
and you got 18, and
Yep.
that's because the syntax is taken. I just was creating the same thing on my own, the name,
Sure.
and then associating it with that integer. So when you call his name, it
Yep.
returns that integer. Okay.
Yep. It recalls. So this key is associated with this value. And so when
Yeah,
I reference it, I reference it by the key and it'll give me the value.
and your uh sorry, your colon
Mhm.
is an operator here telling you the relationship between those two, and then your apostrophe is breaking in the next set. And there's
Yeah,
three sets there.
yeah, the
So,
comma breaks it up.
comma,
You-
comma,
yep,
yeah.
Yep.
Yeah.
Yep.
Okay.
Yep.
But the colon is actually, is it associating
It's associating,
Alex?
yeah. Yep. The key and the value.
It's performing it. Okay, it is. Okay.
Yep.
All right. Thank you.
Yep.
Sorry.
Absolutely. Absolutely.
Would there be a way to kind of flip that around, like put in the value to get the key?
Yeah. Yeah. That's a really good one. So you can
Yeah,
do,
question.
there are built-in, a lot of really cool built-in things in Python. That's one of the great things about Python is that it's really popular. It's frequently used. I'm pretty sure that if you just do this, you can get all the keys as a list by themselves. And then I think, so there's a way just to get the values by themselves. I think similarly, you can do dot. I think it's values. Let's give it a shot, see what happens. Yeah, there you go. And get just the values. And so these things are built in what are called methods. So like everything, we're going to get to classes in Python. Not this time because we're going to save some time for it next week because they're arguably the coolest part of Python, but it takes some time to get your head around them. And so like everything in Python really is a class, and all classes have methods, which are built-in functionality. So like all dictionaries have the ability to give you their values back, to give you their keys back by doing this dot keys thing. And then it'll return them as lists. So then these are ordered in however it was returned when it was returned. And then you can use those to look things up and do all kinds of different operations with them. But yeah, good question. Anything else about dictionaries or lists?
What's the difference between the single and double quotations again?
Oh yeah, so there's really not a huge difference. You just can't mix and match, right? So the reason it accepts both is so that you can do things like in a string, you can use an apostrophe if you have the double quotations on the outside, and that'll work, and it'll stay as double. The alternative is having to what they call escape the special character to make it not break as a string. So you see that the computer kind of forced it into this way of doing it instead of using singles on the outside. But you can use either singles or doubles on the outside in Python as long as they're consistent. You can't mix and match, like this. This will give us an error, a syntax error. As you can see, it says, hey, that doesn't make sense. What are you saying? That answer your question?
Yes.
Okay, cool.
And that open parents, closed parents, you use that on the quit also. So that's some kind of operator, right? It's telling the
Yeah, this is a built-in function. So
function.
yeah, when we start doing functions, which we're going to start doing soon, I'm knock out two other slightly lesser used but good to know data types, and then we'll get into functions. But this is a function. Yeah, these parentheses are what constitute a function call. Cool. Anything else? Right. Excellent. So these things, just like the strings and integers and all that stuff, remember I said you might see literal written, and here's an example of it right there. It says undetermined, unterminated string literal, right? So it meant that it could tell I was trying to write a string, but it didn't end it anywhere because I don't have a matching beginning. I don't have a matching for this beginning part. The lists and dictionaries can also be used. There's built-in functions to call those lists. So if you want to do like a placeholder that the type is going to be a list, but you don't have any information in it, and it's going to be a variable of some sort, you can just save list. You can do similarly with dictionary. And just about everything in Python has that kind of version to it, including the next two we're going to talk about, so these next two types of data are very, I don't know how to put it. So you're going to run across them. They're handy to know, but it's not frequent that you're going to just up and write these, especially when you get going. Lists and dictionaries are going to get you done with just about 98, almost everything you need to get doing to begin with. But these next two, they're good to know. You'll run into them. The first one is called a tuple, which is kind of a funny sounding word, but it is in parentheses itself, and it's a comma separated list, somewhat like a list. It's ordered. It is zero indexed, so we can have things in it separated by commas. It can hold all sorts of stuff. It can hold strings, can hold integers. The difference between this and lists is that these are not changeable, or is what's called immutable. So you can't change these. I'm going to put the word up here. So it's tuple is what this is called. So this is tuple. So if I do anything to this, I can reference things out of it. So I can pull stuff out of the tuple by its index because it is indexed, zero indexed, like a list. And there's a built-in function with it, like you can get the length of it into some other things that you might want to mess around with here. But if I do anything to try to add to this or take away from it, it's going to make another copy of this tuple in memory and not change the original one. So it's not doing anything to the original because it's immutable. That's technically also the same for strings, but we'll talk more about that later. Keep in mind the tuples are immutable. And they're not limited to two things. That two don't get wrapped up on. I just use two as an example for things in them. They could be nested just like the lists and the dictionaries can. And the last one I want to talk about is a set. So a set is useful for certain things if you start doing matrix operations and that kind of stuff. But again, at the beginning, you're probably not going to need sets for anything. They look somewhat like dictionaries, but they don't have key value pairs. So they're stored in curly brackets like a dictionary, but then they just have things inside it. They just have data inside of them in comma separated lists. So just like a list, you could have different types of data inside of it. You can have other, sets, dictionaries, any sorts of things that you want in there. But there are no key value pairs. There's no associating with anything. This is really just kind of like a bag of stuff because it's also unordered. So unlike a tuple, it's not ordered. It can't be zero indexed. Let's do that. Say my set is this, and we have my set now. And so if we try to reference something out of it by its index, it's going to say type error, right? So that's not the same kind of error that we got from a dictionary when we passed it to zero, and if we didn't have that key. If you look up here, we said key error 0, right? So it's a different type of data. So it gives us a different error. And when it says set object is not subscriptable. So subscripting, that's this little square bracket thing attached right to the name of what we were calling. And so you just can't do that with a set. So this just doesn't even work. So because it's ordered, there's other ways you can get stuff out of it, that you can get things into it. You can, check to see if things are in it, which is also really useful. A reserved word of in. So for example, the integer 9 is in my set, but I can use this as a logical statement and just check its truthiness, get its Boolean value back for me by checking. So I expect it to be true because I know it is. So this reserved word in, we'll just check to see if something is inside of that. That works with all the collections. It works on like in this little function it's right here. That works with tuples, lists, dictionaries, and all that stuff, and sets. But again, sets are not something that you're going to be using a ton of. They're unordered. Good to know they exist. They may be a good solution to some math problems you run into, but you're probably not going to use them a lot at the beginning. Any questions about tuples or sets or lists or dictionaries? Does that matter? No questions?
I know I want to take, I made a my kids list and then I made a my tuple list. Two kids were born in one place, the other two in another place. And now I want
Nice.
to try and figure out how to associate those two with each other.
Oh yeah, nice. So to do that, oh sorry, you got another question, Nathan? What's up?
Oh, no, I was just going to ask if you could tell us what level you're at. Like, are you in? So I know you're on a command string, but where are you at in the command string? How would you be able to tell where you are? Because I'm not apparently where you're at.
Like what? Oh, I'm sorry. What do you mean? Like, are you not?
So You have three operands, meaning are you at a lower level or so are you at a different file base? That's what I'm confused
Oh,
at.
yeah. Okay. So this is like a sub process inside of that other bash console that I was in.
Ah,
It's like
okay.
it's like a child console inside of that that's run by Python.
Okay. So maybe I just didn't clear bash console for earlier.
So if you still have the $ and the tilde, then to get where I was, you have to do Python, just the word Python, and then the number 3, and then it'll enter that 3, the interpreter or the interactive shell.
Yeah, I don't think it's working for me, but figure it out.
That is actually an appropriate time to not have that work because we're going to move on to something else. So we'll come back to our bash console, but it is time to actually leave the interactive shell, unless other people have questions that we could keep this open for and keep looking at. It is time to exit this and move on to writing our last data type for today and moving this into creating an application. Any questions before we jump into that?
I don't know if you already went over it, but how would you go through and add or remove things from a list?
Yeah, so I didn't do any of that this time. We'll do a little bit next time. There are a couple of ways to do it. Depends on which side of the list you want to add them to and what you want to take out of it. So you can slice lists. There's a function called pop. So let's see, let me get my list back. Without having to define it. All right, so let's say I wanted to add something to this. I could do append. So it's a built-in function. So I do the name of my list dot and then append, and then whatever it is that I want to append inside of the parentheses. And so this is a way to add something to my list. Then if I look to see that it's in there, the new thing has been added to my list. And that's add something to the back of the list. And so if I want to take something off of the back of the list, you can do what's called pop. And it'll just show you what's on the back of the list. But it also removed that thing from the list. So it returns the thing. So if you want to save this, you could do my list dot pop, and you want to save the last thing from it, you would put this into a variable, right? Like it could be like the last thing variable is my list dot pop. And so now it doesn't give that back to you, but you can see that you saved it. And you can see that my list doesn't have that thing anymore. So that's a way to add stuff, append, add stuff to the back. Pop takes things off the back. You can also slice this and take stuff out of the middle and add things to the front. One thing actually I kind of forgot to add about indexing, which is kind of cool. If you want to get the last thing out of a list. So in this one, there's only there's only 2 items in there. So the last item in it would be our 1 index, right? It would also be our -1 index. The last item of the list is always -1 as well. So you can go negative, like you can go around the other side and do, like go past 0 to index the list as well. So we could do, I believe, we do -2. We'll get back to the first thing on our list since we only have 2 items. But yeah, there's a ton of stuff that can be done with them. So like basic adding and removing things from the back is pop and append. Slicing is probably the way you want to add stuff to the front. And but again, these sorts of operations, when we get into next week, we're going to start talking about how you choose what data type you're going to use, what data structure you're going to use. It really depends on what kind of thing you're trying to make and where you want to add stuff. And it may be better to use something called a queue that looks like a list but doesn't operate the same way. And the way that it changes, like the differences in memory, and we'll talk about what the difference is. But it really depends what it is like you're trying to do in the first place. But that's kind of the methods of adding things to a list. Does that give you enough to go with?
Yeah, it does. Thank you.
Sure.
So, when you do the negative numbers, if you try to do -3, would it exceed the values like it does when you try to do 3?
Yep.
As a
Yep.
positive?
Same thing. Yep. So the list indexed out of range. So there are not that many items in the list.
Okay, so you can't just go round and round and round.
No. Yeah, good question. No, it doesn't. Yeah. Yeah, there are bounds of it. There is a range that it fits into. And then I guess, while we're talking about if we had like, I don't know, example dictionary is a is this, or I don't know, I'll say A is 9. So if I want to add things to a dictionary, like this is basically how you do it every single time. You do it in the same way that you reference things. So if you remember, reference it by its key, which in this case is A, to look something up, right? So a key that exists is referenced in this way. If I want to add something to this dictionary, I could do my example dictionary as if I'm referencing something, but a key that doesn't exist. Like, I don't know, new key. And then I'll close this off and I'll set it as if it's a variable and I'll set it to a value, not starting like that. And now if I reference the dictionary, it should show me that new key value pair. So this is a way you add things to a dictionary if you want to put things into a dictionary. But there's also a whole bunch of really cool built-in functions with dictionaries as well that I encourage everybody to spend some time kind of looking up and playing with. Any other questions? Cool. All right. So we're going to exit out of here. We're going to need our terminal again, but not right now. We're actually going to slide over. Well, we could make it here. We're going to slide over and do this in the GUI though, instead of making everybody doing it in V, because I don't want people to get stuck and get hemmed up with it. But this is something that we could easily do here directly in V. But we're going to do it in the GUI, just for kind of demonstrative purposes, to make sure that we can use all these things. So I'm going to open up this files part. I'm going to do it in a new tab, so I keep my terminal open just so I can flip back to it quickly. And then in here, we're going to make ourselves a new file. I'm going to scroll down to files, and here's my whole list of files. Here's my readme.txt. So I'm just going to make a new file called main.py, main.py. We talked about extensions and names and stuff like that. This kind of a general reference going forward in the course. When I name something, I'll try to call it out when it's a convention. I'll try to call it out when it's required, and I'll try to highlight when it's just an arbitrary choice. But if you're ever confused and you want to know why something is named something, please ask me. Main.py, and that's py, not pi, not pie, it's main.py. That is a standard in Python. It's what a lot of applications will use. You'll see it all over the place if you do things in Python. So that's what I recommend we use this time and keep it called main. But it is somewhat arbitrary. You could technically call this whatever you want to. But so when I make this, I click that new file button. It's going to take me into the text editor of Python Anywhere, which is really cool. It's actually a really nice built-in text editor. So you see this first row has a 1 on it and a little blinking thing, and we can start writing. So when we start doing this and we start debugging and we start seeing some errors, we're going to get to see which row it's on by this reference number here. So these numbers over here on the left are really handy. And this will also do some level of checking the syntax for us before we try to run anything to see if we have any errors in syntax. This is nice to write our code in. So what we're going to do is go over our last data type for today and one control structure and write our first basic application. So the last data type that we're going to talk about is called a function. And functions can be thought of in Python as like the verbs of a language. Everything we've talked about up to now are more like nouns. It's just things, places, ideas, people, right? Verbs, these are going to be the actions, the stuff that actually does something interesting. So we're going to be able to interact with them. So first thing we do is start writing a function. I can zoom in a little bit so it's a little easier to read, hopefully, is the word short for define, DEF. It's a reserved word, so you can't be using this for defining your variables or anything like that. Lowercase with a space after it, and then it's going to expect the name of a function. So arbitrary name. This can be anything.
Leopard.
What's that?
Leopard.
Yeah, you could. We're going to go with main.
Def Leopard.
Yeah, Def Leppard. Absolutely. It could be anything, but the main thing is that by convention, you don't want to capitalize it. Yeah, no worries, Ariel. I appreciate you for putting that in chat. So this can be anything. The title of your function can be anything, but it's by convention lowercase. And usually if you're going to have two words into it, again, you can camel case it, but underscore is more common. So you have more than one word, you generally want to underscore it. And lowercase, right? So we just have a single word, and then it's going to have, whoa, not that, parentheses after it, open, close parentheses. This is where inputs would go, but we're not going to have any inputs in this one. So our function is going to have 0 inputs. And the very next thing after the parentheses is a colon. Now this is going to tell the interpreter to expect what's called an indented block of code. So you've hit enter on this, you'll notice that it automatically tabbed us over. It's going to be 4 spaces or 1 tab. So this is very important in Python. When you're writing in Python, this spacing is very important. You cannot mix and match spacing, and you can't mix and match spaces and tabs. You can only use one. So if you use tabs, like you hit the tab key to move over, you got to do that every single time. If you use spacebar and hit spacebar 4 times to move over to get that spacing, you got to do that on every line. If I do on line 2, tab, and then line 3 spaces, it'll say inconsistent use of tabs and spaces, and it'll break on us. We don't want that, and it's really annoying. So there are, if anyone's ever seen that show Silicon Valley, if you haven't, I highly recommend it. It is an exceptionally accurate portrayal of Silicon Valley. There's a discussion in there that seems unreal, but it's actually a debate about whether tabs or spaces are superior. There are some arguments for why spaces are better to use, but the main thing to remember is that you have to be consistent. You got to choose one and go with it, kind of like the quotation marks, right? Can't mix and match, right? So we're in our indented block, and we are going to give it the next piece that's required in a function, some way to return something to us. And we type the word return to do that. It's also a reserved word, lowercase, no capitalization, and a space afterwards. And we're going to give it whatever we want it to return, right? So in our case, we're going to be writing a hello world application. So we want to return the string, hello world. And we're excited about that. We'll close off our string. So this right here is a fully formed, albeit exceptionally simple, function in Python. This is the basic syntax of a function. You have our reserved word def, the name of the function, our inputs, 0 or more in parentheses, the colon telling us that we're going to have an indented block, and then our return statement with returning something back to us.
So if you put one of those words, like the function words, like return or def, into a string, could you still use them as a non-reserved word?
Question. No, it will not understand it. That's a really good question. No, it won't. So it has to be like this with no quotations. It'll be interpreted as a string, and the computer's not going to understand the content of these strings.
Right.
So
I was asking more of, can you use that in like a sentence of a string?
Oh yeah, absolutely. Like if we wanted to say, whatever, absolutely. And we could put it in here, whatever.
And it wouldn't consider
it's not going to break. It doesn't care, because inside the string, it doesn't mean anything to it. Okay. They're only reserved words in the sense of they're, like variable names almost. So they're not inside of a string. That's a good question. I haven't thought about the distinction, but absolutely, yeah. There's no real restriction on what you can have inside of a string. There's no reserved words in that sense.
It just sees ASCII characters and puts them in place inside the string.
Exactly. It sees that, boils it down to whatever this boils down to in binary. Yep, bits and bytes. So, and again, these are also bits and bytes, but it's just a different set of predefined bits and bytes that tell it to expect this part next. So, cool. Good question. Any other general questions on this structure and syntax?
Right. I missed the part. What does def mean? What kind of variable is that?
So this is the built-in, stands for define or definition, and it's how you define a function. So it's a reserved word that tells the interpreter that this following part is a user-defined function.
Okay.
And so what's going to happen here when this file is read by the Python interpreter, as it's called, it'll start in the top on this first space on the first row, the first line, and it'll read this left to right, top to bottom as fast as it can, which is very fast. And that is called a sequential control structure because it's going in sequence, top to bottom, left to right. So just good to keep track of this. We'll mention it plenty of times. It's the first control structure we're going to talk about. We're going to talk about another one very shortly. But this right here is just defining this function. So what we've done is we defined it. And when I hit save on this, I can save it. There's also in here built in this run button. So again, if you have more than one console open, go to your console window, close the second one. We need a console for this. If you hit run, it should open a console on this screen. Except I might not be able to see mine since I'm so zoomed in. I might have to zoom out just a little bit. There we go. Oh, well, that might be making it worse. All right, so what this is doing is it's opening a console down here at the bottom, and you see it's just a Python console like we had before. And it'll run whatever program we have up here. So this is a way of not having everything disappear in one instance of your Python shell, right? So this is not just saving in memory or saving here in this file. So you can write some more complex things and run it at once and see how it goes. So we're going to do that a couple of times, and then I'm going to show you how to run this from another place, which is going to make this a more useful application, and it is going to be how we run our applications in the future and how all Python applications are run, is being able to call it from the command line in reference to this file. But if you notice, when I hit run, really nothing happened. It didn't do much of anything. There's nothing on this output. I can hit run again, and nothing happens really. So the reason for that is that this isn't telling it to do anything other than defining this function. We're not using the function anywhere. We got to do what's called calling this function and do something with it. So similar to when we were writing quit with the parentheses, we need to do that too with our main function. So to do that, I could just put, main down here, and with a sequential control structure, if I save it and run it, it should run, but it still didn't come out with anything. So a way to get it to come out to the screen is to wrap it in what's called a print statement. And this is a built-in function, which will send whatever we tell it to print out to this area, which is called a standard out. All right, so this should print out our hello world. But this is, again, a fairly hacky way of doing it. We're not going to keep it like this forever. What we want to do is make this a little bit more of a robust, a kind of normal way of doing an actual application and not just running this top to bottom every single time. And the way we do that in Python is with another control structure based on logic, and it's going to check a logical condition and only run this main application if a certain criteria is met. So to do that, we're going to use a conditional control structure, as it's called an if statement. So we're going to use the built-in word if, lowercase if, space, and this is going to check some sort of logical statement. So it's going to expect a logical statement after it. This piece that I'm going to write is a standard in Python, and this is what's called an application entry point. We'll see it again when we do our Django application. This is what every every Python application is used some sort of thing like this construction to do what we're doing. We'll dissect a little bit and talk about it. Let's write it first. So first thing we're going to do is say if space, and then we'll do 2 underscores, and then the word name and 2 underscores. These 2 underscores are showing to human beings that it is a reserved variable of some sort. The Python interpreter doesn't really care. It treats this like any other variable, but by convention, things with underscores mean something, as in to flag for human beings that we should treat it a certain way. And the 2 underscores means that it's reserved. So this name is a reserved thing, and we're going to check to see if it is equal to, so 2 equal signs. So if double underscore name double underscore is equal to, so 2 equal signs. And then we're going to give it a string. I'll give it a single quote string. And we'll put 2 underscores, main, 2 underscores, and then close up my string, colon. So this is the control structure. The if statement is the word if, then the logical check of some sort, and then this colon to tell it that that part is done and we expect another indented block. I'm going to just hit delete to move up our print main into that indented block. So what this is going to do is going to read top to bottom, left to right. It's going to get to this end of line 2 and say, okay, cool. I have this main function defined. And then it's going to keep reading, and it's going to say if. All right. And it's going to say, if this thing is equal to that thing, go in here and do this. That's what this is telling us to do. Any questions yet?
What does it mean on the
I got-
on the console window when it says keyboard interrupt when you hit run?
That's a good question. So keyboard interrupt usually is when you hit Control C to stop something from happening. So I think in this case, it's built into whatever script they have running. When I hit the run button, it does a keyboard interrupt first. But yeah, I don't know. I've noticed that too. I'm not really sure what it's doing on that.
Got a question.
Yeah.
I've seen this many times, but I never understood what it was.
This right here, yeah, actually, absolutely. Okay.
You got to go into more detail. You just explain how this is like a human flag for us.
Yeah,
What
yeah.
is
So
what is the code? What is it doing? How does this see it? What is it?
yeah. So what we're going to do is I'm going to show you what this is going to give us the ability to do. And I'm going to explain it a little bit better. And this is why I left plenty of time here at the end to talk about this, because this is the end point I want to get to today. And I want to make sure we understand what's happening here. So it's good. I'm glad you asked, right? So when I hit run on this, it should largely do the same thing. It gave us back, the hello world thing, and we're all excited. What I can do now, though, is if I'm back in my bash console, and I'm back in the home thing, and if I do ls to show where I'm at, there's my main.py, right? I'll go here and I'm going to make sure I've saved it. So I got the latest code. It's got everything in it. And if I do Python 3 space and then the name of that file, it will run that program and it'll spit out to me here the hello world. So what happened was when I did this, and this is the standard, this is the convention, we're going to do this a ton of times when we're building our program and we're using Django. They call their main.py something slightly different, but they're going to use this same thing, which is called an application entry point. So what this is doing is this reserved name, this thing called name, it's checking to see if it is the main call. And when it is the main call, it's this part of it right here. It's being called directly. It's saying that this file is being called directly as the main part of this application. And Python is treating this as an application. And this is its entry point, is the way that outside systems, in our case, Bash, is able to access these things and able to run these programs. So this whole thing is the application entry point. It's the standard in Python, and we're going to see it when we start running Django. You'll see it if you look at any other Python code. Like you said, Anthony, it's all over the place. So these things are not things you have to actively set anywhere. They're by default this. And if that's not a real clear explanation of it, I definitely recommend that you take this kind of thing and look up in the help articles that we have and in the things about Python. I think in some of the reading at the bottom has good explanations of this. Another great tool for this, though, if you don't understand a little piece of this, is to go over to ChatGPT and ask it to explain this piece to you and see what it says. So that's very helpful. But any questions about that before you go over and do those sorts of things? Any questions about this from what I've explained so far and how we can run it from somewhere else in our computer?
Can you explain it again?
Sure. So what this is doing is when we reference our file, right, from some other place, we're not inside of our program, we're not inside of Python, we're in Bash, and we can even move to a totally different directory entirely. So we're not in the same directory as our main.py file. What we can do is we can reference that by running it by Python 3 and then just the name of that file because of this entry point. Because what we do when we call this thing directly and we say, hey, Python 3, go to this file by name, and we say, go to this file, do this, it'll run through all this and read it, and it'll say if name equals main. It'll do this check. And since we called it in this way, it does equal main. Let's tell you that. So without proving to you that it does, because it's going to get deeper than we want to, that is the case when we call it directly. So it'll do what we tell it to do in this piece right here. And that's what makes this a functioning application that can be called from any other place that you need to call it from, not just limited to right inside of your own code or right inside of a shell.
So the Python, when you type in Python on the command line,
Yep.
and then you pass in this directory in the main file,
Mhm.
name of the file, which is main by.
Yep.
So that passes on inside the code into the underscore name is what's being passed in.
Yep. And it's being passed as main. So it's passing it as setting it to this condition being true. Right. So this is what we're telling.
It says it's checking to see if name is equal to main.
Yep.
But that file name is not underscore main underscore.
It's not. No, that's what I'm saying. There's something underneath this that's because it's being
Oh,
called
okay.
directly as opposed to being what's called imported. So when we come in next time we start talking about classes, we'll do this a little more, and it'll sink in a little better as well as how this works when we start importing other files and connecting other files that we're not going to call directly. So what this is going to allow us to do is we're going to write other files alongside main or in other places. Like, refresh your memory. I'm back in my home directory at the tilde. And that's where my main.py file is. And so we're going to write another file next to this called classes. And we're going to start talking about classes and do some demonstrations with it. But then we're going to be able to reference that classes file by still calling exactly the same way, the Python 3 main.py. And it'll be the main point. The reason, again, that we call it by convention main is because it's the main place that you go to access the other files that you're going to have. They're going to have more directions and more definitions and more variables, more functions, and more algorithms that make your application more complicated than just saying hello world. So this piece right here allows that to happen, where you can tie together any number of files and directories, but reference one file to run the entire application.
Hmm.
Does that help make sense?
We'll see how it goes. I've done a lot of, like I said, a lot of classes. I never understood this, so this is a good class
Okay.
for
Okay.
backing up what this means.
Yeah, absolutely.
And I'm
And
pretty
again,
sure it's important.
yeah, it really is. And it's kind of is the heart of it. Like, what we're doing here is we're writing directions in a file, right? So this is a file. Here's the directory that this file is located, right? /home/ my username / main.py. It's up here at the top, right? And there are directions in this file. These are the directions. This is everything that programming is. It's just files in directories with directions written into it. And this particular part of the directions allows us to link like several files and directories together and make a really complex program, which we're going to start doing that. We do the web application. It's going to similarly have this exact same entry point, but we're going to be able to run all the stuff that we're going to run by tapping through this part first. Is that just confusing things, or is that helping clear up a little bit?
No, that's a good start. Like you said,
Okay.
I can go in on our own time. We can go in and
Yeah, I definitely
Yeah.
recommend between now and next time,
Yeah.
doing a couple of things. So first of all, now that you have this piece, you can put anything up in this part up here. You can make other functions and reference them down here. You can follow this pattern and make more interesting applications. And you can use things like ChatGPT to help you. If you go to ChatGPT and do like, write me let's just do it. So we go to like ChatGPT and be like, write a Python script that, I don't know, converts a video file to audio. And see what it comes up with. And it'll say, yeah, sure. And it'll confidently tell you to do stuff, but then you get this and you can already recognize some of the parts and pieces, even if you don't know everything that's in here. Even if you don't know all the stuff that's in here, you don't understand this import statement at the top. We'll do a lot of this in Python. We've already talked about this though. This is def. This is a function. This is defining a function. We know there's the name of the function. We know that these are the inputs of this function. We know that this is a variable. It's being set to this. You can start following and reading along these things with the hashtag. That is a a comment. So it will not be read by the interpreter. It's for humans to read. So it's not going to be run as code. So it's a way to explain your code in there. So this kind of tells you what's happening without changing anything. But here's that little piece right there. So what you can do with this is you can just take these parts and pieces and just copy it in to the thing that you have and try running it. You're going to have to upload some video clips and, do some things like that. But now you have the same framework. It follows the exact same pattern that we just did. So you've got a function, the if underscores, name underscores, main, and all that kind of stuff. It's exactly like this is. So you could take that, put it over here, play around with it and run it, see how it goes. And this is seriously, this is what coding is. You come up with a thing that you want it to do, and you run it through a program like this, where this is the structure that you're going to have. And you call it by doing Python 3 main.py. And you're just going to do this every single time, no matter what changes you make to this main file. You call it the same way each time.
Hey, am I right that I created this bash console for this session, and then that set of files that go with it, once I delete that thing, this work that I did, it's all gone and I'd have to recreate it? Or
No, so this file will stay here. That's a good question. Yeah, so this bash console and this file are not strictly associated in that sense, that this main py will stay there and you can delete that bash console and it's not going to hurt anything.
okay, so I have a set of files associated with my account then, or whatever. My home, okay, and then, oh, that makes sense. Yeah,
Yeah, so you can go to,
yeah. I was looking at directories.
yeah, I think you'll have two consoles listed here. So here's your main.py one. You could close this one, and it won't break anything in your actual file in here. This is still exactly where it was. And you can still make changes to this. It'll just, if you run it again, it'll just open up another console, but it's just told you that our console is closed here.
Mine still says bash console and a bunch of numbers. Did you name yours intentionally, or how did that happen?
Oh, this one up here?
No, on your console, you had a,
Oh, it said main.py on it. No, that was just
Yeah.
because it was running inside of here. So it
Oh.
did kind of associated with it because it's running the code out of this file,
I
but
gotcha. So
yeah.
it's looking like two files at the moment. Yeah.
yeah. So if I run it again and it opens another console in here, it should put it back to my consoles list, prepended with that main.py
That's
thing.
it. Got
And
it.
then it's also a Python 3 console,
3.1. Yeah.
like up here, right? Which we could go to directly if we wanted to.
Cool.
Cool. So yeah, any other questions? That's the goalpost for today, was to get to this point where we defined the most basic of building blocks, the variables. You got integers, strings, floating point numbers, booleans, collections of things. So variables, lists, and dictionaries being the most important collections of things. Tuples and sets being good to know, less important. And then functions being our last data type that we talked about here. And then we built an application, a very, very simple application, but a fully formed one that can now be used to do other things if you like.
I'm not really using this web browser thing you got displayed here. I'm just using directly Vim directly on my system
Sure.
and my own photos. Is that okay?
Yeah, it totally is. The only thing when we get to building the web app, you're welcome to do all of this stuff on your own console if you want to. But when we start building the web app in week 3, it'll be deployed directly from here. Like we do basically the deployment step first, and we're kind of building live on the web in a lot of ways. So if you do all those pieces, which again, you're welcome to, if you do all those pieces on your own device, in your own terminal or something like that, your own console, then you're gonna have to figure out how to deploy it someplace, which that's not too hard, but we're not gonna go over that. And there may be some differences in how you run things through the development server on your own device than through the cloud part. Just a handful of different commands.
I may switch back to what you're doing at that point, but
yeah. For now, I mean,
No,
it really makes no difference.
We're veterans.
Yeah.
We're veterans. We're not afraid of challenge.
No, I'm not worried about it. And that's the other thing is I can call those different commands out. It's not even that hard. It's just a couple of different things that you do here and there.
Oh, okay.
And then at this point, it really doesn't matter. This is all to show that it's possible. Anybody that doesn't have one, and also to make sure everybody's got Python installed and they don't have to go through installation of your own device or on your own device or any of those sorts of things.
Okay, great. Thanks.
Yeah, for sure. Any other questions about anything?
Yeah, so the 2 underscores.
Mhm.
Why 2? Why not 1? Why not 3?
Yeah, that's a really good question. So 1 underscore, if you look into So there's a style guide for Python. It's called the PEP, PEP. I forget exactly what it stands for, but they always come out with a different number of it. I forget, what number it is now, but it explains what exactly all those things are preferred for, right? There's a reason people use a single underscore, but the double underscores are just ones that are reserved. So there's a handful of things that are, like reserved variable names, and they use double underscores to make sure that they can reduce the chance of having a conflict, right? They don't want to take up every possible variable name. They want you to be able to use things like name if you want to. But they did that, so it's at PEP8. Yeah, there you go. Thanks, Greg. But yeah, that's why it is kind of an arbitrary choice, but it's by convention. So they landed on 2 to mark those reserve things. It could have easily been 3, but I don't know. You know what? I'm assuming there's probably like an actually really interesting story about how they landed on 2. Just like I hear that there's an interesting story about how they came up with the 2-letter abbreviations of every state. I guess that's an interesting story, but it seems like it would be mundane. So. Any other questions?
Oh, this is great. Thanks, Jeff.
Yeah, for sure. For sure. So next week, we're going to dive into some more stuff about algorithms, specifically the choices we make with data structures and types. Before we get into that, though, we're going to finish up with classes in Python classes. So over the weekend, play with these things between now and Tuesday. Practice writing your own, applications, come up with some stuff. Again, leverage ChatGPT and text generative things that can write the code now that you can read a little bit and understand what's happening, plug it in places. There is no shame in copy and pasting. I'll send out, we've got some documentation about the things that we covered today. I'll send that out as a follow-up with this. Slides for anybody that wants them recording, like always. And then again, if you want to work ahead or look ahead at what we're going to do, classes is the thing that we're going to cover on next Tuesday, which is by far the coolest thing in Python. So if nothing else, we can wrap it up there. Thank you all for your time and attention. Have a great weekend.
Aloha.
Thank you.
Thanks, Jeff. Appreciate it.
Yep. Thanks, Al.
Have a good weekend.
Yep. You too.
Thank you there. Okay.